This problem is not exactly the same one from the homework, but it's pretty similar in that it's a linear function and we're trying to see if the limit equals 5, which means we're basically trying to see as n gets ginormous, will this expression get arbitrarily close to 5? I hope if you just even think about this for a few moments, you realize that this, as n gets huge, will just really get large and it won't get arbitrarily close to 5, but we're going to show how the math supports that as a way to understand how proving limits works. So I'm going to say that this sequence, which spits out values that are 5 times the input plus 4, is less than 5, that's center, plus a little bit, but more than 5, the center, minus a little bit. And we're going to solve both of these inequalities one by one. So 5 minus epsilon is less than 5n plus 4. And then, of course, 5n plus 4 is less than 5 plus a little bit. And as I solve for n, subtracting 4 from both sides and dividing by 5 gives me 1 minus epsilon divided by 5 is less than n, or n is more than 1 minus epsilon over 5. And then for this guy, same idea. I'll subtract 4 from both sides, divide by 5. 5n will be less than 1 plus epsilon. So n will be less than 1 plus epsilon all over 5. And this is the problem. Because this happens, it means that at some point there are values for n where this inequality is no longer going to hold. There's an infinite number of values for which this inequality is no longer going to hold. If we have n less than, it means that, yeah, if this is true and if this is true, when both of these guys are true, this sequence is super duper duper close to 5, but that only happens for a finite number of numbers, for n's that are more than this but less than this. It means it leaves the neighborhood eventually, and therefore I can say the limit as n approaches infinity of 5n plus 4 does not equal 5, or that's not the limit, or however you want to say it. I hope that makes sense. It does.